Hi, good afternoon. Welcome to the post-lunch session of the first day. This is Srihita Katkuri, Senior Application Engineer. In the morning, we had two interesting sessions on MISRA C and auto-generation of test cases using telemotive test automation. In case if you have missed attending the previous sessions, they will be available on our YouTube channel. In this session, again, we have a renowned speaker from Buxing, Dr. Roberto Bagnara, who will be training us on usage of the tool ÉCLAIR. We recommend you to use the ÉCLAIR software verification platform. Dr. Roberto Bagnara will take you through all the steps involved in making the code compliant and formulating a sound MISRA C compliance claim. For the people who have just joined, the presenter for this session is Dr. Roberto Bagnara, Chief Technical Officer and Chief Scientist at Buxing. He is also a full professor of computer science at the University of Parma, Italy. He co-authored more than 40 papers in international journals and conference proceedings on programming languages, static analysis, and other techniques for software verification. Roberto will continue the session now. Over to you, Roberto.
Welcome to this workshop session. So those of you who have subscribed have received two things. One is an installer for a trial version of ÉCLAIR, so like this. I assume everyone has already installed it because you also received instructions on how to install it. And also you have received a link, and now the link has been posted to the chat, to additional material that I will use for this workshop. So it's an archive in 7-zip format. In the email you received yesterday or maybe today, there was a recommendation to download 7-zip, which is a free archive program. So I guess all of you can now follow my steps. So of course I only see my screen. I don't see questions, I don't see raised hands, and I count on the Menlopark people to tell me by voice if I should slow down, if there are questions, or if somebody has been left behind, and so on. So this 7-zip file, let's check the name. It's called ÉCLAIR 3.8 Demo CRC Windows GCC ARM 821. So you should have it. I right-click on the icon, and with 7-zip, I extract the file here. Here means on my desktop. Of course, you have no obligations of doing exactly what I do. But I just describe what I do so that you can reproduce it maybe somewhere else. Okay, so now I have this folder, and I can open it, and there is a Readme file, and the Readme file contains some introductory instructions, which you can skip. The point is that in order to install the toolchain that is used in this example, you have to run a script, which is in this, which is in the same directory as the README. You have to run a script which is called prepare.bat. But let us look at it. So I can open it with, I want to see it. So I'm afraid that if I click on open, it will be executed, whereas I want, so let me use this other environment, which is Cygwin, which you don't need to use, but as I am a Unix person, I find myself better with this kind of thing. So I go into this directory that I created. The script prepare.bat is here, and there is only one dependency. So prepare.bat will not work unless 7-zip is installed in this location. So this is a default location where 7-zip is installed. However, if you decided to install it somewhere else, before executing the prepare script, you should update this line of the script. So let me go here. So can I maybe increase the font? Yes, it seems I can increase the font, so let me increase it a little bit. Okay, so I guess you can see better. Now I am in an ordinary command prompt of Windows 10, so I go to, in my desktop, and in this directory, here is where I have a prepare.bat. I can now execute it. And as you can see, what this does, it unpacks a compiler, so a version of GCC for the ARM, and also some utilities, in particular the GNU make utility, which is used to build the small program we use as an example. Okay, so prepare.bat ended well. If you have a suspicion that something went wrong, there are log files here. Okay, for example, if we do this, in my case, everything is okay. This is what the unpacking operation resulted in. Okay, so everything is okay. And now I can continue with the graphical user interface. So as the README explains, the easiest way to launch the ECLAIR graphical user interface is to double-click on file demo GNU ARM embedded toolchain windows.ecs. So before rushing to do this, let me make sure that we are all on the same page. I am doing things as slowly as possible because some of you may want to repeat this same experience we are making today in the future. Maybe you didn't have time to install the evaluation version of ECLAIR. Maybe you didn't have time to do any preparation. And I want that you can by watching at the video that Menlopark will make available, you will be able to do these steps in the future. So I want first to make sure that on this machine, ECLAIR is installed. So all programs, Bugsang, and yes, okay, you see the ECLAIR graphical user interface is available from here. I'm not clicking on it because I want to show you a different thing. So as part of the installation of the trial version, a license has been installed, a trial license. So let me open Google Chrome and let me access this localhost :1947. This is the location where you can access Sentinel Admin Control Center. Sentinel is a protection system which is used by ECLAIR. Okay, so this is the main page. The main page of Sentinel Admin Control Center. If I go to Sentinel keys, I see that I have indeed a license for ECLAIR. And if I go to the features, you see that it lasts 30 days, okay? and that it started yesterday. So yesterday in the early afternoon Italy time, I installed a trial version myself on this new machine in order to put myself exactly in your shoes. Okay, so this is to make sure that I have an installation of ECLAIR, and as part of the installation, I have a license that will allow me to play with the system for 30 days. Okay, so the README says go to the demo directory, and there you will find this GNU ARM embedded toolchain Windows ECS. Now I have made some bad things just before the beginning of the workshop, because I was experimenting about editors I will use in this session. So I am afraid I have told the system to always open these .ecs files with a text editor, whereas as soon as you install ECLAIR, as part of the installation procedure, establishes the association between the ECLAIR graphical user interface and the ECS file. Okay, so I open with the graphical user interface this configuration file, which has been loaded. There is a welcome page. I guess you are seeing. Okay, I'm now increasing the font to make sure that you see well. Okay, so I have just loaded this configuration file, which has you see this one, an ECS extension, meaning ECLAIR settings. Okay, so and the rest of the tabs of the graphical user interface have been filled in with information taken with this ECS. Okay, so the top level directory for the sources is relative to the ECS file is the SRC directory. The name of the project, which is completely arbitrary, is CRC. Now the environment. The environment, I have C/Windows/System32. That is the bare minimum we need, and it's enough to run most Windows applications. And also I have in the path the GNU Make and other utilities we have installed as part of the preparation. And also I have in the path the compiler, so this version of GCC. Okay, and in fact I have in the configuration what it takes so that ECLAIR intercepts all invocation of this C compiler, all invocation of this C++ compiler, and also the assembler, and also this librarian, and also this linker. Okay, as maybe you don't know this, but the way in which ECLAIR works is peculiar. It saves me from all the effort about configuring the tool for the toolchain. So it's enough for me to tell ECLAIR which toolchains should be intercepted, and the rest will be done in a completely automatic way. Services, I am activating two sets of services. One is for the checking of MISRA C 2012 revision 1. MC3R1 is a shorthand used within ECLAIR for MISRA C 2012 revision 1, which is the very latest version of this standard. And also I'm computing some metrics, so I will go back to this later. I am not treating any file specially. You see that this is basically the default and the tasks. As I said, in order to use ECLAIR, I have to tell ECLAIR which toolchain components to intercept, and this was done in this section of the graphical user interface. And then I have to tell ECLAIR how to build the project. So let me start with this. I tell ECLAIR change to the top level directory, and then run make, and with some parallelism. I've said parallelism 4 in this case, even though the project is very small and even though the computer has many more core available. And so when I will run the analysis, ECLAIR will launch the build task, and the build task will invoke the compiler and the linker several times maybe, and ECLAIR will intercept this invocation, and so ECLAIR will know firsthand which compiler is called, what is in the command line, so what are the sources being analyzed, and all that is necessary. So now that you have understood why do I have a build task, I have to explain why I need a clean task. Because thanks to this methodology, only what is compiled is analyzed. And since several build systems are smart, they avoid recompilations as much as possible. For example, if you only modify one C source file, only this one will be compiled. And as a consequence of how ECLAIR works, only this file will be analyzed. This is not what we want in this case, even though this is useful because it allows us to do incremental analysis, but I will not have time to show incremental analysis today. So I define a clean task. The clean task will go to the top level directory, run make with argument clean. Now, settings, I will simply check the rules and I will simply show the reports of the analysis. I only have one configuration for everything, and these configurations are put together here. So services, I have the default set of services. Okay, what is? The default set of services is this one. Okay, I could define another set of services. For example, let me call this set of service bar C 2018. Okay, I have now defined a different set of services where maybe I don't want this, but I want to have all the checkers by ECLAIR for bar C 2018. Okay, so I have now two sets of services. One is called default, MISRA C 2012, and the HIS metrics, and one is called bar C 2018. Okay, so analogously, I can have many clean tasks. In this case, I have only one, which is called default. I can have many build tasks. Think about a library. A library may have many configurations, so you can build it in very different way, maybe with different toolchains. So in this case, you will need different build tasks, different clean tasks. Okay, so in this configuration, I put everything together. Services is default, but if I wanted to do so. For the set of files, I have only one set, which is called default. So I treat them all in the default way. Clean task, I have only one, which is called default. Build task called defaults. For the analysis settings, I want to check the rules. And for the report settings, I want to show the reports. Okay, so now I am at this point where I can run the analysis. Okay, I could save the configuration because I have just modified it, but if I forget to save it explicitly, The graphical user interface tells me, hey, you did modify the settings. Do you want to save? Because if something goes wrong, maybe you may lose your changes. Okay, so what happens? The analysis started. As you can see, this output is not the output of ECLAIR. So by virtue of how the make file is made, we are compiling 3 translation units, okay? And we are linking them together. Okay, the run finished. So now let me show you what we did. So where is it? SRC, it's here. So here we have my sources, and the make file is very simple. So as you can see, in order to build crc.exe, you have to link together these 3 object files. And in turn, these 3 object files, they have their dependencies, of course. They are compiled with the C compiler, okay? CC, which is this one, which is in the path, so it will be found just by this, and so on. And make clean, it simply erases. Oh, there is a bug in the make clean. You see? Let me. The make clean should also erase the executable. Okay. In this case, it doesn't make a difference. Doesn't make any difference, but it's of course it was a mistake. Okay, so the analysis, the run has finished. It has finished normally, so I can close this window that warns me that the analysis was complete. Now I can go to View, and if I go to View now, I can either browse reports in other formats. I will go here later. And if I click on View, I open a page of detailed reports. Okay, so this report says we have analyzed project name CRC. The top level directory is here, users, Roberto, desktop, you know it. And then the analysis took place a few moments ago, so 8:50 UTC. Okay, we have run the analysis with several enabled services. So we have enabled metrics, as I said. Of course, we use a parser. We have generated reports in different formats. We enable 170 rules, and we have 2 tools. Okay, so what happened here? We did 1 clean. We compiled 3 translation units. You remember? Here they are: crc.c, reflect.c, and main.c. There are 3 translation units. We have compiled 1 program because we have linked, we have called the linker just once in order to obtain main.exe. Okay. In total, we have intercepted 4 commands. Okay. The number of analysis files that were that took part in the analysis, they were 30 source files. And you might be surprised. Why 30? Well, because we had a few source files in the SRC directory, but there are many other files in the compiler implementation. Okay, so you see, this one is one of the other files provided by the toolchain _ANSI.h. It has been analyzed. Why? Because it's part of the source code that is compiled. And many MISRA guidelines do require that you analyze the entire source code, no matter where it comes from. So you can see that every source file that took part to the build is recorded along with its checksum, so that we know exactly what we did analyze. And this is, of course, useful when you work in a safety critical sector where you have to provide full traceability of what you did. Okay, good. So now I have this we have seen the analyzed file, so let us see the analysis frames just to reinforce how ECLAIR works. Okay, so ECLAIR recorded that a clean was made, and this was done by make.exe J4. And the producer is a particular version of ECLAIR that has generated this report. Again, all this is unique, so it's something that allows full reproducibility of what we did. Okay, so this is one of the commands that was intercepted. So an invocation of GCC to compile crc.c. Okay, and in the analysis of this compilation, which produced the target file crc.o, we analyzed all these source files. Here are reported again, as you have seen before, divided by directory. So these are our sources, and these are different header files that are part of the C implementation we are using. And finally, we have obtained some reports. So we have metric reports. These are not interesting for us now. We have 130 violations of MISRA guidelines. And also we have 8 cautions for MISRA guidelines. ECLAIR operates a careful distinction about when the violation is certain. So when ECLAIR says there is a violation, then there is a violation. So there are no false positives in violations. Whereas when ECLAIR is unsure, then it issues a message which is a caution. It says, look, maybe there is a violation, I'm not completely sure. ECLAIR also is able to generate other kinds of information that are not directly the sign some guideline has been violated, but that are important to understand what's going on. So let's see this violation. So this project is rather clean. Okay, so you said that you saw that there are 130 violations of MISRA guidelines. However, you can see below here that for many MISRA guidelines, this project is clean. In fact, it is almost clean for the BAR C 2018 coding standard, and starting with this coding standard, you will get a project that has less MISRA violations. Okay, so let us look at some of them. Rule 7.2. Rule 7.2, it's a rule that says that whenever an integer constant is implicitly unsigned, then you should make it explicitly unsigned by adding a u suffix, either lowercase or uppercase, to the literal. Let us see one violation. So this allows me to show you one of the features that only ECLAIR has. That is, allowing you to look at the code before preprocessing and after preprocessing. As you can see, the violation is the main location of the violation is here. However, as you can see, we don't see any integer literal here. Why? If we move the mouse just a little bit below, you we end up in another area, okay, which is the same code after preprocessing. So this is before preprocessing, and this is after preprocessing. And if we move to the next area, we see where the macro is defined. And of course, it is here that we should look. Okay. So let us correct this violation. It's easy. We just need to put a U after this FFFF integer literal. So in case some of you has doubts about what the rule says, one might ask, why is polynomial okay? So let me click on this. So why is this in violation, whereas this one is not in violation? Because this is implicitly unsigned. And why is it implicitly unsigned? Because the most significant bit it has is 1. So the rules used by the C language to decide whether an integer literal is signed or unsigned are quite complex. They depend on the basis. Here we are in hexadecimal. They depend on the size of integer quantities, of integer basic data, in particular the size of int. And on this implementation, the size of int is 32-bit, and also on how large is the constant. And in this case, since int is 32 bits, and since the constant is so large that the most significant bit is set, this is implicitly unsigned. Okay, so I have to change this. Now, as in the email you have received yesterday, you were invited to have an editor. So every one of you should have a favorite editor to change the code. Ideally, I could have used the integration of ECLAIR with Eclipse or with Visual Studio Code, and this would have been much more convenient from the point of view of the presentation, but everybody in the audience would have had to install Eclipse, so the requirements were higher. So I decided to use ECLAIR from the graphical user interface and to use an editor to make the changes. Okay. So let me edit crc.c. And the violation is here in line 52. So it's this one. It's initial reminder. And from this, I can anticipate that there is a violation also here, you see. I've clicked on this red things that tell me, hey, there is a violation also in this line, okay? So while at it, I will correct both. So line 52 and line 53, here I am. I add a uppercase U. A lowercase u would be okay. Anyway, because the rule allows both. I have saved the file, and then what I can do, I can close this, and I can reanalyze. I rerun the analysis. So if everything went well, these two violations of Rule 7.2 have gone away. Let me view again by service. You see, there are no more violations of Rule 7.2. Rule 7.2 is not in the initial part of the summary by service, so it will be in the second part, where there are the gray the gray, okay, here it is, you see? There are no reports for 7.2. So we fixed all of them, okay? So let us look at another violation, 8.13. Let me take the occasion of explaining how this graphical user interface works. If I go here and I only over here, a preview window is opened where I see what is the problem. The rule says a pointer should point to a const qualifier type whenever possible. Okay. Now in this case, I have a my name variable, which is of type of type char pointer, and ECLAIR is telling me to change this to const char pointer in order to comply to the rule. So if I go here, a preview opens. If I click on it, I go directly at the file, and here I can see what's the problem. Okay, so I have to edit main.c. I use my favorite editor. You feel free to use whatever you want. Okay, so my name, it's const char pointer. I want to re-establish the alignment. This has nothing to do with MISRA, but I like alignment. So I align everything, and now I can go back, rerun the analysis, and rule 8.13 should be now okay. Okay, I'm only going through simple violations here, so to make sure that everybody can follow, and we can do the same thing. Then, of course, this evaluation version lasts for 30 days. You will be able to use it on your own code, and you will be able to do all sorts of experiments. And of course, if you want assistance, get in touch with Menlopark people, and you will obtain all the help you need. Okay, so let's see another MISRA violation. For example, 14.4. This is easy, I would say. Yeah, the MISRA rule 14.4 says that the controlling expression of an if statement and the controlling expression of an iteration statement should have essential Boolean type. Okay, so we have some violations here. You see, here ECLAIR is providing explanation, saying, look, this is not a Boolean. Okay, so this is a 32-bit unsigned integer and not a Boolean, and so the type, standard type is unsigned long, so it's not a Boolean. Okay. We have a similar violation here. It's the same file, but it is a few lines afterwards. And we have a third violation here, okay, in reflect.c, okay? Whereas the if statement expects a Boolean in the card. So let us start with crc.c. Now I already have my Emacs alive, and I have it on crc.c. So this is a line to two line 83. Okay, so I only need to convert this into a Boolean. So I write an explicit difference test with respect to 0. There is another occurrence just below we have seen. Where is it? It's here. Let me check. Line 126. Let me expand this violation. Oh, there are several violations here, but in particular, there is a violation of 14.4. Here it is. Okay. So, again, let's code an explicit test with 0. The other was in file reflect.c. And let me go back to refresh my mind. Reflect.c is this one, okay? Data and 1. So it's in line 37, it's here, same solution. Sorry, different from 0. Okay, I have saved all the files and I can rerun the analysis. With the Eclipse interface, we would see incremental analysis, so we would only reanalyze the changed files. However, as I said, this would have required you to have Eclipse installed. So the rule was 14.4, and now all the violations have been corrected of this one. Okay. So let me, what can we do now? We can fix maybe one more violation, and then I will show you something else. Okay. Let me check. Okay, no, this is not the one I wanted. What I want is this one. Okay, so this is a rule of MISRA. It's called Rule 8.4, that together with Rule 8.5 ensures that all declarations and the definition of any object with external linkage, they are compatible. If you have two different translation units where you define same symbol with incompatible declarations, this is undefined behavior. And the solution that has been identified within the MISRA coding standard is to make sure the compiler always can warn you about such incompatibilities, okay? And so the requirement is here to always have a compatible declaration visible when an object or function with external linkage is defined. So what is the problem here? The problem here is that the reflect.h header file is not included in reflect.c. So let me show you this. You see here the reflect function is simply defined. It's not declared before it is defined. Whereas in crc.c, where we have a use of reflect, one or more uses, okay, via macro expansion, you see that crc.c includes reflect.h. Reflect.h is the header file containing the interface of the reflect function. You see, here it is simply declared. So what is the point of this MISRA guideline? The MISRA guideline says you include reflect.h not only in the modules where you need the function, such as crc.c, you also include it in the module that defines the function. So I now open reflect.c, okay, and I add the inclusion of reflect.h. This way, should reflect.h contain an incompatible declaration of the reflect function, so incompatible with this one, the compiler will give an error. It will refuse to compile reflect.c, and this is our protection with respect to this very dangerous undefined behavior. Okay, so let me now run the analysis once again, and we should see that the only violation we had of rule 8.4 has now disappeared. Okay, so view, and rule 8.4 is no longer here. It is somewhere here. Yeah, because it doesn't have any residual violations, so it's clean. Okay. So let me now show you a different thing. So we have browsed the detailed reports view. Now, if I go into browse, you see that there are several other directories, folders. So txt contains textual reports. Okay, so they are generated by ECLAIR, of course. For example, by file is a file that would be helpful if I have to provide a progress report to my manager. So I have the number of reports for each file. For example, I don't know, from main.c, there is 1 caution, 1 information, 11 metrics, and 28 violations. Yeah, okay. The overall gives us an overall view of the last analysis we did. Okay, so which services were enabled, which compiler invocations were intercepted, the total number of source and object files that took part of the build, and the summaries. So in total, we have 8 cautions, 5 information, 54 metrics, and 124 violations. So this for the TXT, but let me, I wanted to show you what an information is. Okay, so this example, Directive 4.4, it says the code should not be commented out. So we have 0 violations, 0 caution, but 4 information. So this is an extra service provided by ECLAIR that will show us which portions of the code have not been compiled, which is always useful because you need to be aware of what you are compiling or not. So this code has several configurations. Okay, so it has a configuration for CRC CCITT, that is an 8-bit CRC, 16-bit CRC. We have compiled for 32-bit CRC. As a consequence, it is completely expected that the portions of code that have to do with 8 and 16-bit CRC have not been compiled. So this is an example of what is an information. There is also another thing I may want to show you. It's explain. Explain explains the configuration of ECLAIR. Okay, So, for example, the project name was configured to be CRC. The project root was configured to be this one. And these are all the configurations that we have. This report is very long, but it's long because there are so many MISRA guidelines, and basically all of them are enabled. So you see that it is all of this form. Okay, so this was for we were looking at what is in TXT. Now you know what is in TXT. What is in ODT? In ODT, we have a summary report in Openoffice format. Okay, so if you have, it is divided in several sections because it's very long. The entire thing is called book. You see that LibreOffice is opened now, and I can, the index has not been updated, so I have to update it manually, update all, okay. So this is an automatically produced analysis report for project CRC. This is the date, which is, again, a few minutes ago, 9/16 UTC of November 3rd. And there are all the informations about the configuration of ECLAIR, about the, you see, a summary of all the rules that have been enabled, and so on. So all of these sections are optional. Here is an exact report of the analysis we did, and in the end, there are summaries divided by rule first and by file. So, for example, for rule 10.1, we know that there are 4 violations in crc.c and 4 violations in reflect.c. So this report is what you can use at the end of a project to be handed to your acquirer. So if you develop software that you have to provide to some OEM, for example, you will have to provide reports, and this is one which is very important, and it has to do with the MISRA compliance of your code. So I don't know how much time I have left. If someone could tell me, it would be great. So metrics. Hopefully I have a few minutes to show you metrics.
Yes,
Yeah.
You can continue, Roberto. We have more 20 minutes, so you can explain the metrics, and then we'll, if you are done with the stuff, we can go for questionnaire.
Okay. Okay, so metrics have been written here. There is no mystery. Metrics are produced in this textual format. You see, I've seen it with Notepad. And this is good if you want to subject your metrics to further post-processing. However, in order to look at them, it is much more convenient if you use a pivot table. Here, ECLAIR writes in this directory 2 pivot tables, one to be used with LibreOffice and the other used with Microsoft Excel. I prefer LibreOffice, so I will double click on this. Okay, so we use macros. As you know, macros are dangerous, but ECLAIR is safe, so I enable macros. And I also allow updating. You see that we are landed in a page where there is an important disclaimer. It says, look, these are thresholds on several metrics, including the HIS metrics. However, these thresholds are examples. It's your organization that should tell you what are the thresholds. Anyway, the use that is made of this threshold is in this presentation, it's very simple. So metrics that exceed the threshold will be presented with a red background. So let me go to the pivot sheet. Let me expand this. You see, we don't have many functions. It's a very small project. So all the metrics are in check, and the only red cell has to do with the HIS metric called return. It means that there is a function which has two return statements, and this is the main function. Okay? So this for the metrics, as I have shown you, I've told you something about bar C, so let me run a very simple experiment with bar C. And so I simply need to have another configuration. So let me clone this configuration. This configuration uses the default set of services. Let me clone it. Let me call it bar, for example. I am deliberately not being consistent, just to emphasize the fact that these are just names and that you choose them. And here I enable the set of services, which is called bar C 2018. Okay? So I have now a new configuration, and when I run, I can choose if I want to run the default configuration or if I want to run the bar configuration. So let me run the bar configuration. Let me save. Okay, we are analyzing with respect to this different set of rules. The analysis finished. So let me do. There are a few violations here. So let's look at some of them. So some const keyword are still missing. Okay, so in this sense, bar is stricter for this aspect than MISRA. So since data is set and never change again, the suggestion is to declare it const. Okay, so this is simple. Let me show you one thing. There is a rule saying in bar C that each module and function shall be commented out in a manner suitable for automatic documentation generation, with the suggestion of using Doxygen and ECLAIR as a checker for Doxygen comments. And you see, interesting this. So here, the Doxygen comment says documents a parameter which is called num2, but num2 is not here, okay? So it's probably the result of refactoring. So at some stage, this parameter was called num2, and then it was said, well, better call it n bits, but the comment was not changed accordingly. So this is spotted by the ECLAIR checker, okay? Let me fix this. So it's not num2, it is n bits. Okay. Let me re-establish the alignment because I like it. And okay, so we have seen a violation of rule 2.2.h of bar C 2018, which is in ECLAIR parlance is NC3. Why? Because in the origin, this coding standard was called Neutrino Embedded C. Okay, this was a version of 2009, which was followed by a version in 2013, which we call NC2. and the current version is of 2018, and this is what we call NC3, the third edition. So let me run again. I hope I have saved the file. Yes, I did save it. Okay. And now, if everything went well, you see 2.2.h is no longer violated. We have violation for 2.2.a and 2.2.b, but not for h because this was fixed. Okay, so last thing, if you didn't have time to request an evaluation version of ECLAIR, and now that you have seen the presentation, you would like to try, then it's not late. You can ask and obtain very easily an evaluation version of ECLAIR. And with the video that Menlopark will make available, you can repeat these steps. And once you have done this, you will be able to use this on your own projects. Remember, you will have to change, of course, the configuration for trivial things like the project name and the top-level source directory. I didn't mention why why I set the top-level source directory. It's not compulsory, but if I don't do it, I will end up with absolute paths. And absolute file paths can be very long and inconvenient. Whereas if I set the top-level directory, okay, let's explain it here, all the paths will be given relative to this directory, okay? Of course, you may have to change the environment because certainly your tool chain will be somewhere else and maybe you want them to be in the path. You will have to put your compiler, assembler, librarian, and linker here instead of the ones that are supplied with this demo. You will have to define your set of services if you want, okay? And for the rest, you can basically leave the same thing, okay? And very quickly, you will be able to run the analysis and to browse the results in the way I've shown. Okay, so if there are any questions, I will be happy to try answering them. I don't know, probably I should stop sharing the screen in order to see.
Thank you, Roberto, for detailing about the working of ECLAIR. All the delegates are requested to drop their questions in the chat box. Roberto will answer them now. Alternatively, you can also drop an email to us at support@menloparktech.com. Thank you.